In this video, we will cover how to set up and calibrate analog channels on a Link Model 4010 analog input module. To begin, I will click on the System Setup button, and then I will navigate to the Analog tab that we see here. Now, Link does offer a couple of different analog input modules. The Model 4010 features 8-pin LEMO connectors and does have excitation capabilities up to 12 volts on our latest modules. We also have a Model 4011 that is a differential analog input module that does not supply any excitation voltage. So that would be used in a case where you have a sensor that is already being powered, perhaps on a vehicle or maybe in a laboratory test cell by some other device. And you just need to look at the differential voltage coming out of that sensor. So to begin, we're going to talk here about the 4010 analog input module that has excitation capabilities. Now, in our previous video, I did show how we can set our default excitation voltage to a different level. I currently have it set to 10 volts, and I can change this on a channel by channel basis. Also important to note, each analog input module has a maximum of 8 channels per module, and if I did have more than one analog input module, which I do not, we would actually see additional channels go further down inside of this table. But the way the layout works is that you have this table with all 8 channels, and you can simply, click back and forth through these here, and then down at the bottom of the screen is where you'll actually do your calibration and zeroing and things like that. So the way I like to begin would be to go ahead and select the channels that I want to use, and I right now have some sensors that are physically plugged into channels 1, 5, and 6. Now, if I wanted to, I could freeform type these in for a description, and I could configure a unit class that I would like to use. Or alternatively, and I talked about this a little bit in the first video, or the general overview, is that we can map to a specific channel, and depending upon what type of testing you're going to do, you can modify your map channel list, and you can have, basically there's about 100 different channels that you can predefine, basically its name, its short description, what the intended unit class is. And so what I'm going to do here is I have a steering wheel sensor that I'm going to go ahead and map. And if I look down here, map channel 161 is my steering angle. So you'll notice once I map this channel, it will actually turn itself on for logging. It will define the unit class. So in this case, the unit class would be angular position, and if I right-click here, you can see that I could change to any other unit that resides in that same unit class. Right now, I am supplying this sensor 10 volts excitation, which I can show you real quickly if we look at the bottom bar on the screen here, which represents the actual raw voltage coming in. If I turn the steering wheel all the way to one direction, it will actually clip. It will actually go to 10 volts, which will saturate the channel. So what I'm going to do in this particular case is I'm going to go ahead and change my excitation voltage to something lower. So we can go as low as 3.3 volts, and we can go as high as 12 volts on our latest modules. The module I have here can only go to 10 volts. But for example, if I set this to something like 9 volts, now, when I move this sensor all the way one direction or the other, I won't actually clip that signal. Now, the sensors that I'm using here now are a high level output. So if I put 9 volts in, I can essentially get up to 9 volts back out. A lot of the sensors that you would interact with on a daily basis for like pressure sensors and things like that wouldn't necessarily work in that same fashion. Typically, a lot of times those would be a millivolt type output. And when you use a millivolt type output, we would potentially need to use some gain settings here. So right now with a gain of 1, essentially anything that I bring in, I am not doing any amplification to that signal. So you can see I go down to 0.4 volts all the way up to 9 volts by completely going through the stroke of this particular sensor. Now if I was to change this gain, now you see anything that comes in, I'm essentially going to double its output. Right, and in many cases with a millivolt type of sensor, you might be using gain settings in the 4, 800, sometimes even 1,000. You can go all the way up to 8,000 for very, very small millivolt type output signals. So I'm going to go ahead and change my gain back to 1 so that I don't saturate this channel. And I'm also going to show you how to do a couple of different ways to calibrate this sensor. So down at the bottom of the screen, as long as I'm selected here, you will notice I've got this bar is lit up red right now. And that's because I saturated that channel. This is a warning that can be suppressed in your user preferences. But if I click on this now, that will go away. So I'm acknowledging that that channel is saturated, which is typically not good. If you're collecting data and you saturate a channel, you lose the ability to actually get to read the full signal. So in the lower part of the screen, you'll see that we have the ability to provide some sensitivity information. So typically, a more high-end transducer that you might interact with, you would get a calibration sheet that might tell you that you have 50 millivolts per some engineering unit, and you could set a maximum level. I will show that later, but for this sensor, how I'm going to calibrate it is using our 2-point calibration method. With the 2-point calibration method, really you just need to know 2 known values so that it can set up your slope of the line, and then you can zero the sensor externally if needed as well. So in the case that I have here, I'm going to use minus 360 and plus 360 degrees, as this is a steering angle sensor. Now, it is important to note, anytime that you are interacting with our Link software and you're inside of a text box here, you want to make sure that you hit the Enter key. If I type in a value and I just simply hit the tab, or if I type in a value and I click away, that value will not be saved. So it is important that you actually hit the Enter button. Okay, so now what I want to do is I'm going to move my steering wheel all the way to one direction, and I'm going to hit the Set Low button. Okay, so now it's waiting for me to hit this Set High button. So now I'm going to move the steering wheel all the way to the other direction. I'm going to hit Set High. Okay, so now that I've done that, now if I take this steering wheel back to the center, you see that I'm roughly at 0 angles here, and I can go from negative 360 to positive 360 without actually clipping the signal. Now, if for some reason I needed to zero this channel, so I want to leave the linear relationship that I have set up between these 2 points, but let's just say now that something has changed on the vehicle and this no longer reads 0, what I could do is click this 0, 1 channel button. That's going to zero the channel that I'm on right now. So it's going to change its 0 offset while still preserving the low and high point calibrations that we entered in to establish the linear relationship from volts out to degrees of angular rotation. Now we do also have the ability to apply a 60K shunt resistor across 2 pins on the LEMO connector, and we can also do a cal shorted, which in the case where you have a shunt resistor that is built into your cable, you can actually apply that electrical shunt to the sensor. We use this quite often on sensors like load cells and pressure transducers, where we may have a sensitivity method that we enter in to do our calibration, but then we use a shunt resistor to verify that with a 59K or 60K load from a resistor, that the sensor is outputting in the way that we would expect it to. So that is a nice feature that we have built in. So I'm going to go down and set up channels 5 and 6. And so channel 5 I have connected to a throttle, and then channel 6 I have connected to a brake pedal. So similarly, in this case, I'm going to go ahead and right-click in this map channel cell here, and I'm going to go down and find throttle position, which is 168 here. And while we're at it, I'm just going to go ahead and select something for my brake on channel 6. So I'm going to go up to, let's say, pedal travel. Okay, so excuse the jumping around, but I'll go ahead and jump back up to channel 5 here, which is my throttle position. And right now, if I provide some input to this sensor, this is going wide open throttle, and then this is backing off completely. So you can see that we've got a decent range here. This bar would represent -10 to plus 10 volts DC that we're able to read, and you can see the raw voltage here. So I want to make sure that when I go wide open throttle that I use as much of this available range as I can without actually saturating that signal. Now, if I was to change this gain to 2, now you'll see when I actually go wide open throttle, I actually exceed the limits of what I can measure there. So that's not good. So let's go back and change this to a gain of 1. And this time, instead of doing a 2-point calibration, I'm going to use the sensitivity. So essentially what we have is it's about 4.7 volts to get 100% throttle. So if I switch this to sensitivity method, and I say that 4.7 volts is 4,700 millivolts at 100% throttle to a maximum level, and this is how it's going to set up my gain for me, would be at 100%. Okay, so I can apply the sensitivity right now, and when I do that though, because I didn't enter a millivolts at 0%, my zero offset is going to be off. So we can tell right now that as I am not putting my foot on the throttle, that we have a voltage of about 2,700 millivolts. So there's two ways that I could handle this. One way would be that I could just go and actually zero this channel, and that will still preserve my relationship that I've established here for the slope of that line while forcing it to be 0 now, so essentially just moving the 0 offset. Or if I go ahead and just reapply this sensitivity, what I could do is also enter in the value that I'm seeing here in millivolts. So we're seeing essentially about 2,706 millivolts. I hit enter, and you'll notice the apply sensitivity button lights up. Go ahead and push that. Now we can see I'm down to 0. When I step on the pedal, it goes up to 100%. When I release the pedal, it goes down to 0. Now for pedal travel, let's just do our easy 2-point calibration. So I'm going to say that I have 0 and 100 millimeters. So right now my foot is off the brake. I hit the set low button. And something I did want to show is, I want to show you if I just apply a little bit of input to this sensor and I try to hit the set high, you notice it's going to tell me that the difference between the high and low settings is less than half a volt. So in order to accommodate a calibration, we do require that we see at least a half a volt DC change in between your two different calibration points. And really what we're trying to do here is aid the user in making sure that they're using as much of this range as possible. Now, if I needed to, let's just say that this sensor isn't a high level output like I'm interacting with here, I could turn the gain up. So now a very small input is actually going to give a fair bit more output from what we're seeing here. I guess I do actually have to click the gain, sorry. So now a very small stroke will actually see that will have more of an impact here because we're essentially doubling everything coming in. Okay, so I'm going to go back now and I'm going to set low and then provide 100 millimeters of stroke to the sensor, and I'm going to hit set high. Okay, so now this sensor is close to 0, this sensor is close to 0. I'm going to move my steering wheel off just a little bit. So something else I wanted to illustrate, that if you need to, like before each event that you captured, that you want to make sure that everything is completely zeroed out so that you've got really clean data, you can do that on an individual channel by channel basis like I showed before. Hit 0 one channel, hit 0 one channel here. Alternatively, and especially if you have a lot of channels that you need to zero, this could be very beneficial. We have this multi-zero field, and if you turn this on, you're going to notice that you're going to get this 0 multi-channel button. So anywhere I'm in this table here, if I hit this 0 multi-channel button, we should see all 3 of these channels get zeroed at the same time. Okay, so you can see that that's happened. So while I only have 3 sensors right now, that might not be super important. You get to where you might have a couple hundred analog inputs that all need to be zeroed simultaneously or before you start going collecting your events. That could be very important. So I did also want to show in the analog input module here, and like a lot of our screens, we can load and save settings. So if I had a complicated array of analog sensors here that I wanted to be able to save this, I can click the Save Analog button. And then when I do that, I'll be able to save that file, and it's a .ana file extension to anywhere that I want for being able to pull that in at a later point on a new test. We also have the ability to set some filters. And if I do that, you'll see that we have a few different options here. So we can select a software low pass filter. So we could turn this on and then set it to a given frequency. You can choose the number of pulls and then filter your saved data, turn that on or off. And then we also have another filter here, anti-aliasing filter that can be turned on. And just to clarify the point on filter save data, if turned off, this will provide live data to be filtered, but as you save the data, it will still be saved in its raw form. If you turn this on, essentially whatever filtering you have here will become your saved data set. So as a word of caution, if you over filter here, it's not possible to unfilter the data later. Typically in your post-processing, you do have the ability to do filtering and things like that. So it really just depends on what you're using and how you need that to look on your live display on whether you should use those filters or not. This concludes our analog channel setup. Thank you very much for watching.